Good morning. It is Friday, April 2nd. We are closing out the third quarter and ending another week of our remote learning. I do see, in terms of questions that I'm getting and, you know, people liking and viewing the videos from the first one that I put up, which I had like 60 something views on. People must have been watching it, going back and looking at it again um, to the last one where I did have a slight uptick after I said though, people weren't, and I was seeing the number of views. I just want to remind you that at some point in time, you will be back in school. You will be applying for colleges. We don't know what the governor is going to do. The governor might turn around and say everyone has to come back to school in July and take a regents exam. Look, at a whim, he took away your April break. So, what's to stop him from saying, I want these Regents exams to go through? Uh, Maybe we'll have a week of review for those Regents exams. I mean, who knows what's going to be planned? I would keep current. You can fool the system for so long, uh, but at some point in time, there is going to be accountability. And those of you that are not, being honest in terms of what you're doing and trying to beat the system, it will catch up with you. Anyhow, if you could take out the questions that I had assigned, I asked you to do the 15 entropy questions and the first 10 of the kinetics and equilibrium review test. Uh, the schedule for next week, Monday, I'm going to do 11 to 45, finish them up on Thursday. If you have on Thursday, on Tuesday, if you have questions at any point in time, post them. Post them on Edmodo. Post them or email them to me. Uh, Post them, message them on Edmodo. Anyway, I go back and check all my resources. And those of you that have put in questions, I'll either post an answer back and then also do it online. So please reach out to me. The number of questions that I've been getting have dropped. I think I'm a good teacher, but I'm not that good where no one has any questions after I've explained and gone through the material once. So uh, you have to have questions. I'm not that good. You know what I mean? So please ask. All right, I'm going to start with the entropy ones because that's the order that I assigned them. Or at least I think I did. Doesn't really matter though. But I'm going to start with entropy. I think the entropy is the easier one. The general review, those 80 questions, you'll probably have more questions on. But starting with number one, the amount of randomness. Randomness is entropy, so it's the entropy of the system. So simply underline that one word, randomness, and you know the answer to the question is going to be entropy. Systems in nature. Okay, rocks want to roll down the hill, and we want to be messy. Things need to be disorganized and at lower energy as a preferred state in the universe. 3. Which equation represents a change that can result in an increase in disorder? A. It's starting as a solid. Solids are neat and organized. Gases are disorganized. So I'm going from a solid to a gas. That shows an increase in entropy. Uh, B is the exact opposite of it. Remember, we call that deposition. Uh, 3, you have a gas in it, like sodium, which is a solid, but then chlorine is a gas. It becomes sodium chloride, a solid. So entropy goes down. And letter D, okay, you have three gases on the left, right? Two H2s and one O2. Remember, we use a coefficient to count our number of moles of change, and then it goes into 2 moles of a liquid, okay? So number 3 is A. 4, increase in entropy, liquid to gas, choice C. Number 5, which 1 mole sample has the least entropy? Okay, we have 2 samples of bromine that are at 266 degrees. Temperature does matter, but more important than temperature is state of matter, so it would be A. Number 6, Which reaction has the greatest increase in entropy? Uh, A. It goes from 2 moles of a liquid to 3 moles of gas. Right? Choice B also shows an increase in entropy. It's 2 moles of gas to 3 moles of gas. That 2 increases. However, A has a greater increase in entropy because it's starting as a liquid. Number 7. As reactants form products, the entropy of this system we're starting off with a solid and a gas, and then it's becoming only solids. Solids have the lowest entropy, so that entropy is going to decrease. Number 8, as products are formed in the reaction, okay, the entropy of the system. Okay, you're going from a solid to aqueous ions. That means in the liquid state in solution. So it's a mixture. Mixtures have greater entropy than pure solids, and the liquid state has more entropy than the solid state. So uh, entropy of the system increases. And now circle the 3.5. That's on the left, indicating endothermic. So heat is absorbed. Number 8 is C. Number 9, circle the 26.4. That's exothermic. And now on the left, we have a half O2. It's a half a gas. And on the right, we have a full CO. That's one gas, increases in entropy. So that's A. Sometimes in these reactions that are referred to as formation reactions, they do use fractions. It's infrequent, but does happen. Number 10, an endothermic reaction might proceed spontaneously. Let me explain to you why they refer to it in that way, that they may proceed spontaneously. Endothermic reactions are not supposed to happen. A rock is not supposed to roll up the hill. The rock is supposed to roll down the hill. I guess it could roll up the hill if it's a light rock or a sponge or something and wind brings it up, but it requires energy to do that. The wind is a form of energy, it's a form of kinetic energy. It can push something light up a hill. But things in nature tend to go to lower energy. So, what must do it? Entropy has to make it happen. Wind is a form of increasing the entropy. It's causing a mixing effect to our atmosphere, distributing heat instead of having pockets of high temperature and low temperature or high air pressure and low air pressure. The wind, causes those pressure gradients or pressure differences to mitigate themselves. So the fact that we have winds driving reactions or wind driving things increases the entropy. So that entropy change can drive a rock up a hill. Thus, the answer to 10 would be C, entropy. Entropy can make things happen. Probably enthalpy makes things happen more than entropy because energy change is a great difference. And exothermic reactions actually increase entropy because they're releasing heat into the environment, and more energy is more entropy. Number 11, the Gibbs free energy formula. You know what? I did not review that, and it's not testable anymore. It is here, but I'm going to give you the formula for it. Delta G is equal to C delta H minus T delta S. The delta G, when delta G is a negative number, reacts as a spontaneous. We used to use the Gibbs free energy equation to explain spontaneity, when things are spontaneous or not, when a reaction will happen. But the answer for 12 does not depend, your knowledge to answer 12 does not depend on you knowing that free energy formula. It's just knowing the conditions for spontaneity. And it's delta H negative and delta S positive. Increase in entropy, more random, decrease in enthalpy, decrease in energy, exothermic. So the negative delta H means exothermic. That you are responsible for. It's actually in your reference table of those thermodynamic values. And entropy, we talked about increases in entropy, positive entropies are preferred by the universe. 13, okay, given the reaction, okay, delta H is negative, okay, the energy is on the right, so that's good for the universe. It wants to be spontaneous, and then it increases in entropy. It's going from a solid to liquids, so the reaction must be spontaneous because delta H is negative, and it's inferred that delta S is positive by producing the the solution, the mixture, the liquid. 14. Which potential energy diagram indicates a reaction that occurs spontaneously? It has to be one of the exothermic ones. So uh, A and B are endothermic, so they don't necessarily have to be spontaneous. I'm going to put X's on 1 and 2. Now, C and D, right? Notice in D, it's going from a solid as a reactant to a gas. So it's going down in energy and producing gases. That is spontaneous. And in terms of the remaining choices that we just crossed out, A and B could be spontaneous. It depends if the entropy contribution to the endothermic reaction is enough to cause it to be spontaneous. Like an example of that is evaporation. Evaporation is going up in energy, it's taking on energy, but a liquid will change to a gas to increase in entropy. Most reactions occur because of enthalpy, but some reactions do happen even if they're endothermic because of entropy. Entropy and enthalpy both cause reactions to happen. And number 15, that type of reaction is a decomposition. Okay. 1 to 2 is decomposition. I know decomposition isn't necessarily going to be on this particular topic, but I'm working on the assumption that they're not going to throw away the Regents exams. They have them made, they're stored, they're ready to go. So I don't think they're going to throw them out. I think they're going to make you come back in July and take them. So continue to study, continue to, stay on task. And letter B, explain in terms of particle behavior why the entropy of the system is increasing. On the left side, the reactant side, only have a solid, but what do we have on the right? A gas, you say. You're right. Yes, I'm going crazy. I'm talking to the computer. I need people around me. All right. But yes, a gas. Okay. I'm going to do the first 10 on the kinetic and equilibrium review test. If you have questions going forward specific to 11 to 45, post them, email me them, message me on Edmodo. I will read it and I will pay particular attention to those. Or if the ones that we went over today, you thought you had it right and you didn't have a question, but I said something that was not clear, let me know. The only way I know if I'm not clear or not doing a good job is when you let me know. Okay? And I want to do a good job. Starting with question number 1. A reaction is most likely to occur when colliding particles have proper orientations, 2 ingredients, proper orientation and energy. All right, you can hit the ball. You can be a baseball player, if we ever play baseball again. You can hit the ball as hard as anyone else can, but hit the top half of the ball, with the bat, the ball's going to go down and not up and over for a home run. You can hit it at the proper angle to get it over the fence, but if you don't hit it with enough energy, it's simply going to be a fly ball. Okay? 2 ingredients, energy and orientation. Okay? What is required for, why is this important? Why am I mentioning baseball to you now? Because we're talking about collision theory and what is required for a chemical reaction, an effective collision. That would be C. If I didn't say it, the answer to number 1 was D. 2 was C. An effective collision between reacting particles. If the reaction is going to occur, the particles have to collide with enough energy and the proper orientation. Okay, which is the answer to the next one. All right, it's like this was done on purpose. Right. 3, a reaction is most likely to occur when reacting particles collide with enough energy, proper orientation. C. Number 4, 2 reacting particles collide with proper orientation. What else would they need? Sufficient energy. And that's kinetic energy. So they don't collide soft, they collide with enough force. Kinetic energy is energy of motion. And remember, the reason for that collision is that potential energy diagram. They have to have enough energy to get up that hill. I guess for you guys, after this image changes to go left to right, it should be like that. I don't know. You know what I mean. But it's got to be the here. It's easier if I draw it because it appears to be the same way on the screen, right? That's an endothermic. In order for the reaction to occur, okay, we have to get up this hill the activation energy. So this should come all the way down here, right? Let me see that. Is the lighting okay? Can you see it? I don't know. Okay. And if we have more effective collisions, the more they collide, the more we can react. So as the number of effective collisions increase, the reaction rate will increase. The energy to get up that hill that I just drew is called activation energy. So if they collide soft, they might only get halfway up the hill. They collide hard enough, they make it to the top, become the activated complex, and then form products. Now we're getting into the section where we discuss the factors that affect reaction rates, what speeds them up, what gives us more effective collisions. Right, starting with number 7. Okay, for a reaction at equilibrium, which change will increase the rates of reactions? C. All right, it'll increase both the forward and reverse reaction rates because you'll get more effective collisions. Uh, in most aqueous solutions, as temperature increases, the effectiveness of collisions between reacting particles. You know what? It says most. The answer is B, increases. It's actually all. The thing is, in some reactions, if it's an exothermic dissolving, okay, as you increase the temperature, they do have a tendency to shift in the other direction. It favors an increase in temperature favors the endothermic process. It doesn't mean that it's going to slow down the exo, but the endothermic process is going to speed up more. That's why if you heat ice, the heating of ice is endothermic, solid to liquid. Oddly enough, at higher temperatures, freezing is faster, but melting is even faster. Number 9, which change would increase the rate of any reaction at any time? D. By the way, if I didn't say it, 8 was B, 9 is D. And the last one, which factors has the greatest effect on the rate of a chemical reaction? Solution concentration and temperature. Molecular mass, right? C and D both say molecular mass. That's GFM. GFM isn't going to affect the rate. Light molecules can react as fast as heavy molecules if they're both in the gaseous state. Okay? Uh, and then solution pressure. Okay, here's the thing with pressure. Pressure affects gases, right? In this equation, it's AgNO3, AQ, which means it's a liquid state, and Cu is a solid state, so pressure won't affect uh, that reaction. Okay. Uh, pick it up tomorrow. Uh, it's right now I'm looking outside and it's starting to brighten. It's about was it 8:47? It's almost 9 o'clock. So it is starting to brighten. They said it's going to rain most or all of the day today. Who knows? But if you haven't been as enthusiastically going through your lessons, uh, it's not too late. You will be taking a test next week. I'm going to post it Wednesday. You can take it Wednesday or Thursday or Friday, whichever you like. You know, we're supposed to keep our learning continuing. As the governor said, continuity of learning. So we are going to, continue over the break. What I need you to do, wait, let me see if I can pause this without, hold on a second. I hope this doesn't